Hi everyone, my name is Victor Bonachea with Schneider Electric, and I'm joining you here from Data Center World in Washington, D.C. today. Joining me is Jim Simonelli and Manav Patel, two other experts in the data center space as part of Schneider Electric. You know, you guys have been here since the start of the show, I think actually yesterday.
Yep.
How's the show going so far? What do you guys think?
Oh, it's great. You know, what's interesting is I've been to a few data center worlds, but you know, just kind of we're looking at the data hall right now, and it is extremely packed, very vibrant even at this time of day. You know, everyone's here, lots of buzz and discussion, and I can tell you the talks are very interesting, very thought-provoking over the past day or so.
Yeah, it's interesting. Everything's packed because I've been doing some power industry stuff for a while, and we're always talking about how density is getting higher, and the show is no different. It's super loaded, it's busy, there's a buzz in the air. Manav, what do you think? How's the show going for you?
No, Data Center World this year, it's exciting. You know, compared to past couple of events, this show is literally packed. Right, so many companies, so many peers here. Right, a lot of exciting conversations.
Yeah, it's been great. You know, I've been walking around. The word that everyone's talking about is AI. I don't think that's news for anyone who's even remotely involved in this industry. Overall in the power industry, I'm coming from the AC distribution side, backup power side. We've been doing data center for a while, but now I keep hearing about, with AI going on, DC keeps popping up, right? The old Edison versus Tesla thing, right? What's going on? What's this comeback of DC? What's happening?
Yeah, so what's interesting is oftentimes, you know, I think that when we think about 800 volts DC, we think about it from the supply side, from AC versus DC. The reality is that is absolutely not the case right now. The driver for 800 volts is exclusively around the compute side. So what's happening and what all the buzz is here, and even at NVIDIA GTC, is the fact, look at, if you believe that an AI data center, as it evolves, its most profitable thing to do is to produce tokens. Mm-hmm. The best way to produce those tokens is to use GPUs. The best production of those GPUs is use the latest GPUs, but they also, to get them to be the most productive, you have to pack them very tight. That means denser. So we're dealing with things that used to be 9 kilowatts per rack, then maybe 20 kilowatts, 30 kilowatts. Then a few years ago, it was 60 kilowatts per rack. Today, we are producing those same GPUs in structures using Vera Rubin that are 250 kilowatts per rack today. Now, all of that is supported by AC distribution today. No real chasing space. However, there's another click happening, which is now when you go to Vera Rubin Ultra, the density in that rack gets so high, close to 600 kilowatts per rack, that bringing AC power at 400 or 480 volts in just becomes untenable. There's just too much stuff in that rack that really needs to be just for compute. So one way to solve that is just serving the IT rack itself, is to say, what if I doubled the voltage from 400 or 480 up to close to 800 volts, such that I have the current, and then that means I just use about 1/4 of the copper just to bring power into that cable. That leaves more space for compute. I can put more of that tokens more tokens production in that same footprint itself. So it's completely driven by the compute side, not by the supply side itself.
And that has to do with taking out a lot of my conversion equipment from having to go from AC to DC at the individual component level. Is that right?
A little bit, yeah. So largely what it means is that think of it more as a bit of a copper problem, a bit of just being able to take converters outside of that rack and move them someplace else. That's the main driver for that. So,
great.
Yeah.
Manav,
Yeah, so like Jim described, right, to me, I see this as a physics problem, right? That you need to get a certain amount of power within a rack. And we believe over 400 kilowatt, it's not possible to get the traditional AC VIPs inside the rack. So if you increase the voltage, you can reduce your current, right? And get a higher amount of power.
You get the higher efficiencies out of it.
Exactly, right? So some of those are kind of a big drivers why over 400 kW, we think that these physics work better in favor of direct current distribution. And there's multiple ways to address some of those distributions, which we can talk about.
Now, I hear the NVIDIA name linked to 800 volt a lot. What's that connection between NVIDIA and the 800?
So it's not so much NVIDIA per se. They are the leading driver of the GPUs going into that space. So it's really around accelerated computing, of which NVIDIA is mainly the driver. So AMD has their own chips in that space. And really what happening is that as you pack as their evolutions evolve from their Blackwells, the Rubins, the power dissipation per chip increases. That power distribution puts more density, as Manav was talking about, and getting power into those chips with a reasonable amount of copper means that you have to change something. The thing to change is actually the power architecture to increase the voltage to decrease the copper. And that's kind of where we sit. And I know that it's easy to say, but there's a lot of things that have to change around that to make that happen.
And they're the leaders going into it, basically.
Right. That's right.
Can you tell me a little bit more about what these architectures look like? What do these systems look like? How is it changing things?
Yeah. So a few things here. So one is, as we talk a lot about power right now, right? Which is interesting because things that aren't changing is these are all, when you get up to this power level, these are all still liquid cooled racks. They still need the same type of liquid cooling heat rejection schemes in and of itself. But how you bring power to the rack is very different. It's not typically an AC busway with bringing whips down into racks. It is actually around doing a few different things. So step one is, we call it a sidecar or a power rack that we recently announced, which allows,
that term,
allows us to bring AC at a megawatt level into a rack right next to the critical IT load. And that converts from AC right to 800 volts DC with a small cable or small cabling that runs right into the IT rack. That is a very scalable and effective means to deploy AC without completely disrupting the data center architecture in and of itself. So that's the first evolution that we have that Schneider has been leading. The second thing is that we see the next step is, we call it centralized 800 volt DC, which is real. Now this gets closer to your Edison perspective. We actually have distributing 800 volts from the gray space or back room right out into the data hall. That is another type of architecture that also is evolving. It has other implications beyond just the converters of different sizes. Those can be anywhere from 4 to even 9 megawatts at medium voltage or low voltage Fed type systems. Those are big architectural bricks that Schneider is driving in those spaces as well. But it's not just around the conversion, it also is about the distribution and protection as well, which is all that stuff has to work as a system. And that's partly where Manav and I kind of also are trying to collaborate. It's not just around one thing, actually about how this whole thing comes together. So we're thinking about the conversion, the protection and the distribution, both from a localized sidecar perspective, but also how it's going to evolve over the next few years to a centralized perspective, which is the buzz you hear here. A lot about it is about that centralized perspective. Well, it's not here yet. Everyone is preparing for that, to prepare for when those chips arrive or those racks arrive, which is projected to be late 27 or early 28 in that time frame.
And you mentioned so many different systems, like the distribution, the protection, all that. Over the years, AC has had so much evolution there, so much focus. DC has always been kind of so much lower, closer to the load. So I think there's a lot of catch up to be happening around that. The DC side, is that why there's so much work happening around it too?
Yeah, and I think between Manav and I, so you think about the notion of that, like we know how to do it. Technically, we know how to do this, both breaking and protecting on DC versus AC. We do this in many systems as well. But to do it at scale and at a safe and scalable manner that ordinary electricians and licensed electricians and AHJs can support that. That really is the increasing challenge in that space as well. Which is really, I think, the next evolution is maybe less around the things and more about how do you get the approvals to get the things in the market at scale.
Yeah, and absolutely, I agree with Jim. So some of the constraints, right, the way we like to think, it's not about a component, right? You can have singular components which work fine, but our approach is to solve this at an architectural level, right? So we want to validate from conversion, protection, distribution down to the racks. The system works in a harmony, right? Other key constraint which we are solving for is we want to deploy these systems at scale, right? What data centers care about is speed, time to market, scalability, right? So we want, if people want to deploy these at a gigawatt scale, we need to be ready to help them with deploying these. And Jim also attributed, it's not about one architecture, right? There's multiple variations of architectures which are possible, right? At minimum, we see at least 4 to 6 variations of different type of architecture, depending on what customer is trying to solve for, right? A customer may have a different constraint for the resiliency, backup, right? And some of those other constraints, right? Which is going to dictate what type of architecture a customer is going to choose for.
Gotcha. And I hate to keep bringing it back to AC, but that's kind of something everyone understands, so it's a good comparative piece. AC evolved little by little over time, right? Since the advent of electricity, right? It became our standard. Now the DC piece, it's going so fast, right? We need the capacity, we need to figure out some of the solutions at scale, like you guys said, to quickly deploy some of these data centers. Are those bringing some challenges to the market overall? And how are we addressing those challenges? What's going on to take care of some of that?
No, Victor, that's a great point, right? So some of the things, right, which are evolving is what we kind of attributed in the last conversation as well, is what we call as an indirect ecosystem. So in addition to having the technology to fill the pieces, we need to get the whole ecosystem ready. And by ecosystem, let's first start with the codes and standards, right? The safety comes first. We want to deploy systems which are scalable safely, right? So the codes and standards, we are working very closely along with our industry peers to uplift the UL, IEEE, NFPA codes, to name a few, right? And we're working very diligently to accelerate this. Now, what we need to do is, historically, these codes and standards, they move slowly. We're taking our best efforts to solve as an industry, how can we scale faster? How can we move faster, right? To de-risk some of these topics. In addition to the codes and standards, you think about contractors, you think about electricians, right? There is the skill set and understanding of this DC system.
Familiarity.
In general, it's on the lower side. So we need to work with consultants, contractors, electricians, even AHJs to help them understand these systems at a much better space.
And you mentioned some of our codes and standards involvement, things like that to drive the industry as a whole. Can you share a little bit more on what kind of involvement we have going on there? What types of changes, what standards are we trying to drive exactly?
Yeah, absolutely. So I think we have been part of what is called the CurrentOS community, which was a pioneer for the DC protection system. Since then, we have joined Open Compute project, and our team, along with the industry, has been working very closely with our peers and the OCP community to create a framework around a white paper, right, which helps create some awareness. What are the challenges to solve for? In addition, we are working with UL, identifying the gaps, what are the codes and standards to be solved for, and we are working with different bodies to accelerate some of those conversations.
How are you finding the adoption going? Because education is such a big piece of this, I gotta imagine, right?
Yeah.
How's that going so far? Everyone's on board, everyone's fighting in the same direction?
Everyone in general is trying to fight in the same direction, right? At the end of the day, all of us want to deploy these systems as fast as we can and with what the market needs are to help us with this accelerated AI curve, right? So everyone is generally in the same direction, but a lot of work to follow.
Yeah, and I think the only thing I would add, the governor of all of this is while we have good aligned interests between the compute providers, the data center builders, the equipment providers, safety is at the paramount. So at the end of the day, it's not just around dollars and cents about doing it in a safe manner, which is why it does have to move at a deliberate pace. And I can certainly say that through these bodies, which used to take years to kind of just collaborate to decide on what dinner might want to be had at the meeting, is that everyone's very, very focused to try to drive to some degree of commonality to allow for scale, but also ensure that we are dealing with safety and reliability in that manner as well. And if anything, that will be the governing headwind to deployment.
As you guys say, the thing that comes to my mind is kind of some of the NASA dynamic, right? We want to go fast, but we want to do everything safely, right? We want to accomplish that mission together, right?
And that's the maturity across the industry is at in this space.
So the whole 800 volt is coming from that power density, but that's just the power side of the story, right? That's linked to the entire ecosystem of the data center with the evolution of that. Are there other pieces connected into this other than just the density at the rack level? What else is involved?
Yeah, so I think, just trying to wrap this up, a bit into just kind of put a wrap around the whole system, right? Which is the fact that we really think about this as an end-to-end problem. So 800 volts is just one piece of the power problem. Or power challenge, I don't want to call it a problem, the ability to kind of, how do I provide 800 volts? But remember, building a data center is about building a system holistically. Think about it from a design, simulate, build, operate, maintain. Those things don't change, AC versus DC. They're just happening at scale. That is one of the things we have to keep our eyes on right now. Right now, there is 0 800 volt DC racks in the system today, but it still is growing very fast. That's just going to add another complexity, probably in the late 27 or late 26.
Almost like figuring it out as you go, almost.
Yeah. so those, but the idea is that's why I talked earlier about the fact that some things that we've actually solved some problems very quickly, credibly and quickly, have been on the heat rejection, liquid cooling dimension. We kind of have that problem solved technically. It's now about scaling that problem. We understand that if you want to build these things with certainty, you better have the right software and the right simulation tools to be able to kind of ensure that when you build, you're building with a certainty that's required, and also now in terms of operations that you can actually visualize and understand what's happening at these sites. And ironically, we're using AI to get more effective at operating these AI data centers as well, which is a big...
We're creating our own demand there.
Creating our own demand.
So it's a good loop, I like that.
So that is kind of, if I had to back up and say, hey, let's be clear that we don't over-index just an 800 volt conversation. A lot of the fundamentals are the same. 800 volts is a critical area, primarily to enable the planet to begin to use this higher end compute, this higher end tokens. It won't be every token is produced by these ultra high density, but where it is, it's pretty important. So we better prepared to do that. But that whole end-to-end system from grid to chip and chip to chiller, inclusive of the software and services to maintain it across design, simulate, build, operate, and maintain, is really kind of where the crux has to maintain, and that's really what we have to keep moving forward.
So I think a lot of people are interested to learn a lot more about this topic. It's changing every day. Anything you recommend for people to kind of keep up with what's going on?
Yeah, so I got to say that if this topic started around white paper, around 800 volts. White paper 213 is the paper to read if you want to get an overview of that topic and how to think holistically about that.
And that's available on the Schneider
on our
website,
Schneider website.
Right?
You got it.
So I mean, thanks guys. I guess one last question: like, what's the most exciting thing that you guys are looking forward to in this evolution coming on?
I'll tell you straight up.
Okay,
I'll tell you the most exciting thing is how we can is kind of what's next beyond how do we use AI to actually self-improve ourselves. We touched upon that right now. We're so focused on producing tokens. I'm really excited how we use those tokens to really impact the industry moving forward.
Yeah, absolutely. And for me, it is, I like to think about this as how do you solve problems quickly at unprecedented rate at scale, right? So this is an exciting time for us to kind of get ahead of the curve and solve for these problems at scale.
Those are much more insightful answers than mine. I just can't wait to have ChatGPT. I walk into the house and it does everything for me, right? So that's really what I'm looking forward to. And we're all driving towards that goal together, right? So
great.
No, so the show's been great so far. I think we still got some more time at the show over the next few days. I think we're going to invite everyone to come out to Data Center World, visit us here at the booth. Thank you, and we look forward to continuing this journey with you guys together and evolving the market. Thanks for the conversation, guys, and the education.